No matter which business you are running, it depends on people, processes, and information technology. So keeping your IT services online is essential to drive your business. In case of an IT incident, such as performance issues or outages, you need a quick solution. Even better is to prevent such a situation proactively, because it's costly and can damage your reputation.
Thank you for joining us today on our YouTube channel. And today I would like to talk about the Octopus methodology, one of the methods that we at Knowledgeriver prefer to work from in order to analyze and understand infrastructures. The document again is split into several pages, and you can read to the front pages of it. I would like to start on this page where we have our ITIL description of incidences. An incident is an unplanned interruption to an IT service or reduction in the quality of an IT service. Clear sentence means we have an immediate problem, we need to solve it and get rid of it. The second part of the sentence is even more troublesome to me. Failure of a configuration item that has not yet affected service is also an incident. That means we have a configuration problem lurking in the back that can hit us anytime and can reduce our performance, give us access loss, data loss, even data center outages. All of them are related to configuration management, and we need to understand where they are coming from, how they can impact the infrastructure, and how we can mitigate them. And this is the sole purpose of Knowledgeriver, to provide you the tools and the methods to understand these issues and eliminate them. And the Octopus methodology is what I would like to describe now to you by going through this white paper that you can download from our homepage, and that you can also get on LinkedIn and a couple other places within the internet. The Octopus methodology is based on 3 items: data center monitoring, support package management, and interoperability matrix management. These are the 3 key methods within Octopus that provide us the needed information and the tools to automate these processes. The main objective of Octopus is to collect data from all resources within the infrastructure. That means server, storage, SAN, backup, network, applications, everything that creates configuration data, can be wrongly configured, and what also creates logs and error information logged in some places. So all of these items belong to the Octopus methodology, and they just describe and define how to implement this for all the environment, for all the customer environments. So let's go through a couple of pictures within this document. You can read through the pages by yourself. I just want to give you a short introduction of what we want to talk about in this document. Of course, we have the overall process, and you have your customer infrastructure with your monitoring and performance data, hardware, software, IT security. You have different sites, you have different network segments, you have change, incident, problem management. All of these items are well established. We know why we have to have them. What we see, unfortunately, is that many of the infrastructures collect data on demand. On demand is nice, but if it is not a coherent collection, means I collect my information from all my resources surrounding me. I will always run with one eye shut to a problem and focus in one direction, while the real problem might be a totally different resource that I do not have on my radar. So by setting up the radar of the infrastructure with the Octopus methodology, data collection of performance, monitoring of all hardware and software data within a single item, within a single directory structure, you have now the options of building references to your incidents, of course, by dating the package, and you link this to an incident. You can now pick particular vendors who you want to ask for an analysis of their own support packages, and you can ask somebody else, a third party, Knowledgeriver, for instance, to analyze all the packages, also to get a concentrated analysis done. And then you have a decision tool. The decision tool in our case would be a Manati VM that contains all the data, that gives you an easy access to all of the information, and from where you can then drive the implementation into your infrastructure. So this is the overall idea, and there are of course things that need to be ironed out. One of the things is, how do you set up this data collection? It's usually a master-slave configuration. You have a single master sitting somewhere, and he is driving its slaves to collect the information that you need. Here we do this with batch files and shell scripts. They are located on NIM server, task services in Windows, on monitoring server, everywhere in the infrastructure. The point is that you, as the customer, have complete control over the entire data collection, and nothing is done with strange projects or with strange programs that are running on your infrastructure. You only execute the command that you would execute on the command line by collecting this information, and then you can do the analysis of the data that you have approved to be analyzed on a separate infrastructure. So nobody touches your environment at all. That is the key. You do not have anybody from the outside touching your environment. You provide all the information needed to analyze the problem. Now, within a single network segment, this of course looks also fairly straightforward. You have maybe our Octopus tool that you have configured, that where you have resources that do not allow an SSH key communication, and that you have to have a user ID and password encrypted somewhere to do the data collection. That is usually done with a DC360 Octopus, or you have a NIM server, a task service under Windows that allows you to collect all the information. You have IBM I scripts, IBM Z scripts that provide the information on a single data store within the infrastructure that allows you now to store the data whenever you like. The implementation is based on this single data storage, 2 to 10 terabyte, whatever. It depends on the size of your infrastructure and how much configuration data do you want to save for analysis or for later reference within your infrastructure. We recommend to keep at least a 3-year window alive with data. The first year maybe with every month, the second year with every other month, and the third year with maybe only 4 packages. So this is the main package sizes that you will need for your infrastructure. Then of course you need to have access to this shared drive via NFS, FTP server, SSH share from another server. So all of these communication paths to this data store need to be available. Each of the elements has access to the local store. So this is the local store that everybody has access to from the inside of your data center. Everybody else is connected via a firewall, and you control the direction. Does this pair of analysis server can read and write to this centralized data store? It's one way of doing it. We would recommend to have a read-only connection here, so that somebody from the outside can read data, but he cannot push data into your data center. So this is the isolation layer for your environment. But now you can allow somebody from a home office in Germany, from another vendor, to connect to these VMs and run their analysis. So the other thing is, you do not need to send out data to somebody. You keep the data within your controlled infrastructure. Of course, there are other methods. For instance, you have somebody within the country. Within the country, you have a service provider that you allow to connect and mirror your Manati configuration, so that processes can be done within the country, and the office in Germany from Knowledgeriver can attach to your in-country service provider. There are many configurations where we have implemented this for customers. Again, here I would only recommend to have a read direction for the Manati here, so that we can read data off that you have sent into a particular directory for analysis, and we will do the analysis this way. And of course, we can do this from as a software as a service provider for you in Germany. We would have to upload the data that you would like to have analyzed up to our German server, and we will do the analysis on our side. So there are many ways of providing this information to us, and allows you to have the data analyzed that you want to have analyzed. The process view, the overall process view is, we have several sites here. We have the Manati and the collection process over here. We send the data once a week into this document, into this data store, and from here we feed this information into your problem change, incident, CMDB, DCIM infrastructure. Now you have straight from the hardware and operating system coming information pushed into your management infrastructure. A little bit different view. Again, you have all of your infrastructure, all of your server, SAN, storage, application, data collection done. The data collection is done by your team. You are responsible for your infrastructure. You collect the data. We just provide you help to run the script or create the scripts. But at that moment, when you have done this isolation here, the data all of a sudden is available without touching your infrastructure. And this is the important part of this methodology. You isolate your physical hardware in the data center from the vendor who needs to analyze packages, and you can do now a pre-analysis on this data by yourself, or you ask Knowledgeriver to do it, and ask for a quarterly report on all of the different views into your infrastructure that can be made by having the interoperability matrix data, by having the support packages and performance data, and this will give you a much higher stability in your infrastructure over time. One of the use cases for this methodology, for instance, is SRE in DevOps. It's a clear, structured process where the tools provided by Knowledgeriver are connected to your infrastructure, collecting the data, filling up the data lake, having the Dolphin infrastructure, Dolphin and Manatee infrastructure to analyze the existing data of today and the historical information, and letting all of the information flow in direction of your normal actions and predictive alerts that you have in your environment. This is a clear use case that is described from a different angle, but has the very same outcome that we actually promote. Here's our Manatee. It is connected to all of the outside management tools, and we have Dolphin as the brain of the infrastructure to analyze and send out the needed warnings and alerts to your infrastructure. Now, this white paper describes how to set up the networks, the subdirectory structure on the shared drive, so that your teams, your IBM Z team has a directory, your IBM I team has a directory. Now they will only have access, read-write access to this subdirectory, and it's their subdirectory, and you will be able to trigger Unix, VMware, Windows, network, storage, whatever team you have on this centralized data store. All of the information are stored now in a single directory, in a single drive, in a directory structure, and one of the key items is that you have a higher level authority who can write to all of these directories and create a trigger file. A trigger file that allows somebody in a cron job, in a scheduler job, to look for and understand, if I see this file, then I need to do something. And it's basically a mailbox system. You have a configuration and data directories, script directories within the each of the directories. Now here we will have the in the config we will have IP addresses, and we will see the different IP addresses for the different resources. They are all stored in here in order to have also a centralized place for manipulating this data collection infrastructure. You will remove resources, you will add resources. This is the only thing that you need to change in the future to really collect new information from new systems. That is the key of having a configuration directory. Now, the start of a process is happening by having a file with the IP address of the data collection server collect the text. Within here you will have a single string. This string is year, month, day, hour, minute, second, when this data collection should happen, and you write this file out to all of the systems that you want to have data collected from at this moment. Here are a couple of scripts in here that describes the functionality. If you are able to read the scripts, fine. We can explain them line by line to you if you're interested, and we can discuss what is the intention of the things you want to do. The the external trigger sh file is the one that you need to run in a scheduler or cron job. The cron job will look every minute, every 5 minutes to see, do I have something to do? That's its only job. If I have something to do and there are a couple of conditions, if nothing was run, okay, I will start immediately, but is a process already running, then I will just shut down and will not do anything. So it's a fairly simple decision that need to be made, and there is a locking mechanism here to not have multiple processes running. And the external trigger sh file will start the server inventory sh. In the server inventory sh file, now you will handle all of the items that need to be handled by this server. It could be an IM server who has access to all of your Unix infrastructure, and it needs to collect the Linux SOS package, the Solaris Explorer, AIX Snap, whatever type of package needed from a vendor of this operating system, and also the server, the HMC scan and the iLoom data collection. Everything is done from here, and it will just start the process and wait until it's finished by polling for log files that we will find here. They end with they have this string within it, and now we will wait until everybody else has everything done, until we release the server and post back to the executor, tell him, okay, I'm done. This is done in here. You can download our Octopus tool. Octopus has not only the Java tools to store user ID and the password in combination with an IP address and collect the data from this resource. It will also have all of the scripts that we describe in this white paper to you and allow you to basically set up your data collection by yourself. We will always be willing to help you doing this with our support. Here's an example for an AXCollect script. It will set up a default directory, but if you pass in the parameter, it will use this as the parameter path. It will then start an AIX snap for each of the IP addresses listed in here, and if there are more than 9 processes running in this script, more than 9 processes running, then it will wait until this one of the processes has finished before he starts the next one, if he has more than 9 AIX systems to collect from. This number is arbitrarily. We will set this up during our setup of the infrastructure to understand, when we understand what is the capability of your NIM server and what can he handle. The snap itself is another script that is just sending off the information to with SSH and SCP commands in order to allow you to move things along. Linux implementation, Linux SOS report, so it always is the same type of mechanism. You have a collection, and then you have a snap or SOS report or whatever type of information you want to collect. Same on Windows. Windows also has the WIMC infrastructure that allows you to do the very same thing with batch files, also an external trigger, a server inventory batch file, and so on. So this is all done the same way. If you need any help with the implementation, of course we can do this with you, and not for you, but we can do it with you. You need to understand the scripts, and you need to be able to manipulate them over time in order to keep the data collection coherent and useful for your infrastructure. Thank you for listening to our session.
Did we convince you? Well, then visit our website knowledgeriver.com and discover further helpful services.
Or just send us an email to contact@knowledgeriver.com.